Okay, review for your quiz tomorrow. We did not get to factoring, so this 4.5, this is what we're going to do next, so if you want to look it over and do it, fine. Otherwise, let it go until after Thanksgiving. Okay, number one, I'll do the odds, you guys do the evens. I'm going to put this in a calculator. That's the easiest way to do this. So I'm going to put in my y equals button, and I'm going to put in -3 square root of x. And then now that plus 7 is out of the square roots, so I'm going to close a parenthesis and then put the plus 7 because it makes it go up or down. Then I'm going to graph it. Oh, and it looks like my window's a little off, so I'm going to go to zoom, standard to the default, and there's my square root graph, right? Then I'm going to pick off some good points. Yeah, you better take it this time, Zach. You better take your slip this time, Zach. Okay, so I'm going to go to, oh, they want us to label the transformations. So yes. I had to close a parenthesis. Some of you might have just a box. Close the parentheses. Sometimes you just have to move your cursor over to the right with your arrow key. Okay, so it depends on what kind of software you got on your calculator. Okay, now, yes, ma'am. Get another one. Alright, so, fantastic. So I'm comparing the transformations to the y equals square root of x. Now, what are my transformations here? Now, be careful that 7 is outside of my square root. So it's got to go up 7. What else? Not up 3. Vertical stretch of 3. Good. Vertical stretch of 3. Now, somebody said something about that negative sign. What's that going to do? Yeah, well, I don't like the word flip. It reflects. If you put flip, I'll be happy with that. Okay. It actually reflects. Okay. So let's get some points and easily graph this thing. Okay, so let's go to our chart. And notice that we can't take square root of negative numbers, so we get all those error codes. Oh, because that's my A. Because of that 3. That's actually the slope. Well, go to zoom, hit your zoom button, and then hit the key, number 6, standard. And it defaults back to its. Okay, so this 3, that's my A. Remember, all these formulas that we've been working with, like vertex form, the first one we learned was the absolute value. Okay, remember A was our slope. That was our vertical stretch. It's the same thing with the square root function. Okay, that A is acted as a slope. So it's a vertical stretch. What if it would be just, my A would be 1. If there was no 3 there. Okay? There actually is all of this stuff in our parent function. Okay, there's a positive sign here instead of the negative. There's an A there, it just happens to be 1. Okay, there's actually a 0 there under the radical, and then there's a 0 outside. That, if I were to make this like our regular functions, stretch it out, that's what it would be. But our parent functions, we just simplify everything to that. Okay? Well, if it's under the radical, it's left or right. It's opposite the sign. And if it's outside the radical, it's up or down. Okay? Right, correct. If it's under my radical, it's left or right. If it's outside the radical, it's up or down. Okay? All right, so let's get some good points here. Okay? I've got, it starts at 0, 7. Here's a good point, 1, 4. That's where it starts. And then 4, 1 looks like another good point. I think that might be enough. Well, there's one, 9, -2. So let's plot those points. You could probably do it with 3. 1, 4, 4, 1, and then 9, -2. So here's my graph. Okay, that fourth point really kind of helps. What's my domain? Domain is the x values, right? Where does it start on my x-axis? At when my x is 0. Good. It includes that point, so I'm going to use a bracket. But then I look at my x-axis, and it goes on forever and ever and ever. So it's infinity. Parenthesis. Okay. What about my range, my y values? Where does it start on my y value? I'm coming this way. Where does it start? It ends at 7. But where does it start? Yeah, negative infinity. Good. All right, section 10.3, circles. No. Because if it has a shift underneath the radical, it's going to move your domain left or right. Like this one, number 2, you're moving your x-axis to the left 4, so it's going to start at 4, -4. Okay. Any other questions? Yeah, let's keep going. I want to get at least the odds done for you, because the evens are another problem of the same kind. Okay. So number 3. We'll try. Okay, was 10.3 circles. It was actually pretty easy. We're going to actually get back into circles and do some really hard stuff. Okay, so circle, does everybody remember the formula for circle? X minus h squared plus y minus k squared equals radius squared, and our center was hk. Now, this was pretty easy because the center and everything that comes out of these parentheses is opposite the sign. Okay? So, looking at number 3, I have a -9 and a -6, so it's going to be +9, +6. My radius is the square root of 81, or 9. Okay, what we did with circles was pretty easy. In fact, I think all of you did real well. What? remember, now that's a good question because a lot of students get confused here. Sometimes you won't have the 81. Sometimes they'll put, well, 9 squared. Okay, don't take the square root of 9 because it's already in that form. It would still be 9. Does that make sense? Be careful. They're kind of tricky with that sometimes. You want me to? Okay, number 5. Write an equation for a circle that is centered at -2, 5, and has a radius of 7. See, my radius is already 7. So that means I have to square that. Or you could put 49. It doesn't matter. Okay, so I have x. Now it's opposite the sign. So it's +2. And don't forget this is a y here. A lot of students will put x. And then y minus 5. Okay? Now, like I said, circles to this point has been easy. It gets really difficult when you come back from Thanksgiving. You will eventually. Okay. Alana, it's being recorded. All right, vertex form. I even put them on the board. Y equals a times x minus h squared plus k. I know a lot of you have worked with standard form, but I'll tell you what, vertex form is so much easier. Okay, the vertex form is really easy. Sure, it's no big deal. You guys really, I don't want you to worry about memorizing these. Okay, vertex. The vertex is h comma k. And this time, it's opposite inside parentheses and the same for k, as far as signs. Axis of symmetry is x equals your h value. This is the x coordinate of your vertex, so that's the line of symmetry. Axis of symmetry. Does that make sense? If this is my vertex, okay, suppose I got a parabola, and this is my hk, well, my axis of symmetry is a vertical line, so it has to be x equals this h value. Okay? This is standard form. Okay. How do you find the axis of symmetry? Well, first you have to find the vertex. Okay? The vertex, or the x value of the vertex, equals -b over 2a. Okay? Once you find that x value, that's your axis of symmetry, right? X equals -b over 2a. And then what do you have to do once you find x to find the rest of the vertex? You have to plug it back in. Okay, so that's how you find the vertex. Your vertex is -b over 2a, and then you have to find y. You have to plug x back into the equation to find y. This is actually kind of a lot more difficult than vertex form. Okay. We did problems. You did problems in your homework too. Well, then you went to Google Classroom and watched all the videos, right? Good. Okay, page 2. Now, I think some of you, page 2 came out on a separate page. Okay, so vertex form, number 4. If you have it in vertex form, it's actually pretty easy to do it without a calculator. It's almost easier. Okay, my vertex, remember, inside the parentheses, it's the opposite sign. All right. Outside the parentheses, it's the same sign. So it's -4, -5. My axis of symmetry, x equals my h, which is -4. So I have -4, -5. I want one smaller and one bigger. This is my parabola. -4, -5. Yes, parabola. I'll tell you what, to find the first point, it's a parabola. I had a student that always said parabola. And I always made fun of them, and now I say it. Oh, all the time. I make fun of them. I'm sarcastic. That's my motivation for them. All right, so I could. What? Did I? Oh my gosh. Okay, so I just make a bigger dot. What? Yeah, it's x equals, it's my x coordinate here. Okay? Well, this is my vertex, and I picked one smaller and one bigger. Okay? So I could go back and plug it in and get the numbers, do it in my head. But my slope here is 1/1, and your first point uses that slope. So I can go up 1/1, up 1 to the left 1. And I then have -3, -4. And of course, -5 is going to be -4. And if we really want to check myself, it didn't work. My little slope trick didn't work on this one. So we can't cheat. X plus 4 squared minus 5. Graph it. Go to my chart. And let's see, -5. Oh, it is -4. Yeah, it did work. Okay. So we can cheat. That's lovely. -3, -4. -3, -4. -3, -4. Yeah, I plugged my equation in. And then I went to my chart. Okay. I did do it off the top of my head. That's why I probably confused you. Sorry. Again, vertex form is a lot easier than standard form. Are you ready? We need to do a standard form, right? All right, let's do number 7. When it's in standard form, don't waste your time. Just put it in a calculator because it's going to be a lot easier. And hope for the best. Negative. And make sure you use the negative button, not the minus button. So -3 x squared minus 6x minus 1. Graph it. Okay, now, if you're lucky, and most of the problems on test and quizzes in Algebra 2, you can, guys, You can figure out what the vertex is by going to your chart. Again, most of the times you can do this. Hit second graph, go to your chart, look for your y value that starts to repeat. And it looks like -1. See it? So my vertex is -1, 2. Now, if you're not that lucky, there are problems where you can't, your calculator isn't going to do that. Then you have to use that -b/2a for the formula for the x value, find x value, plug it back in, and get the y value. Okay? I'm hoping. I'm pretty sure I didn't. All right. Axis of symmetry. Yes. Please put x equals -1. What? Yeah. I could tell you if I put 0 in for x, I'm going to get -1 for y. Right? You should be able to see that pretty easy. If I plug in 0 for x, I'm going to end up with -1 for y. And since it's a parabola, the other side's going to be the same. Or you could look at your chart. Okay? -1, 2. -2, -1. And then 0, -1. And there's my parabola. Okay, now this is where the next section, a lot of you weren't listening to me and or there were a lot of students absent. Okay, mathematical modeling. We spent 3 days on this where you guys didn't even turn in homework. So pay attention. Okay. Again, this middle term is our initial velocity, right? V sub 0. Why do we need to learn this? Okay, that's our V sub 0. Velocity. Okay, and this was our initial height. I'm going to fail. Okay. And then we talked about what the -16 represented, feet per second gravity, acceleration of gravity. Okay, so what I'm going to do is, I'm actually doing your problem, right? I'm going to be putting this into my calculator. Again, please use the negative key. -16x squared plus 185x plus 4. Now, remember, our height is our y-axis. Our t is our x-axis, okay, for time. Now, when I go to graph this, what do you think is going to happen? If our scale for our x and y-axis is 10, -10 for min and max, it's going to be off the chart, right? Because of this value here. Yeah, I've got one line of the parabola. Okay, yeah, I'm going to really have to zoom. Since this is 185, my y, I'm going to make like 200 and see what happens. So I got to go to my window. And I'm going to make my y max like 200. Let's see what happens. Then graph it. I went to my window, and I put 200 in there for my y max, and it's not even close. Yep. So I'm going to put it to 600 and see what happens. Now, you actually don't need it for this problem, but I want to show you how to do this. Okay, because you're going to need it for other problems. I'm going to graph it, and look at that. I captured that parabola. Now, same thing with my x max. My x max is at 10. If I put it to 20, I should capture that other side, right? So I'm going to go to my window, and for my x max, I'm going to put at 20. And I should capture my parabola. I went to my x max and put it to 20. Now, again, you don't need it for this problem, but there are other problems where you're going to have to get this in your window. Okay? And that's how you do it. Does that make sense? Change your y max and your x max to get that into your window. All right. So all they want us to do is find the time. Remember, your time is your x-axis and your height is your y-axis. So they want us to know at the time at 2 seconds, how high is it? Time at 3 seconds and 4 seconds. Where can I find this information? Second graph, my chart. Okay. Let's say I'm going to go to 2 seconds. My y is at 310. So at 2 seconds, this arrow is at 310 feet. Uh-huh. Now, what's the rate of change again? That's your slope. Oh, so. Huh? Okay, your rate of change is your slope. In mathematical terms, we'd like to say the change in height over the change in time. So they want it from 4 to 2 seconds. Well, our height is 488 minus 310 over 4 minus 2. So 488 minus 310, let's see, it's 178 divided by 2. So my average rate of change, let's see, is 889 feet per second. No, that's an equals. It could be negative because it could be coming down. .89 feet per second. It's not too bad, huh, Ariana?
So all the tests tomorrow will have a problem like this. Obviously a problem like the current phase.
We got one more. Okay, let's do number 11. Okay, here's my equation. So I'm going to put that in my y equals button. Clear that one out. Negative 16x squared plus 132x plus 7. Now, remember my window is pretty screwed up. We changed it quite a bit. Let's graph it and see what happens. Actually, it's not that bad. We can live with this. Okay, maximum height. Now, this time, we're going to have to find our vertex. Okay, for the maximum height. Because we need that point at our maximum, right? So we're going to have to calculate this. Hit second, trace. See, we want our maximum height, so number 4. And we have to do that left bound, right bound thing. So make sure you're to the left of the vertex. And hit enter. Then go to the right of the vertex and hit enter again. Doesn't matter. As long as you're to the left of it and to the right of it. You can be anywhere. Again, you have to have left bound to the left of the point and right bound to the right of the point. Doesn't matter where, just as long as it's to the left and right. Are you with me? Then hit enter again. And my vertex is 4.13, 27925. Now, which one's my height? 279, it's the y-axis, right? What? It doesn't like you. You're welcome. You look so sad today. You look so lonely and sad today. That's right. Did you get it? Want me to redo it? Okay. So I put my equation in. Okay. Then I was lucky enough to have my window so that it captured the whole parabola. So I hit the graph button and I got my parabola. Okay, so here's what I did. I need my maximum. That's the vertex. So I'm going to hit my second button and trace. And I'm actually going to calculate. Okay. Now I want my maximum. So I'm going to scroll down or hit the number 4 and hit enter. It's asking me to the left. I don't care where your cursor is, as long as you're to the left of the vertex. Hit enter. Okay, bring your cursor back to the right of that point. Anywhere is fine, as long as you're to the right of it. Then hit enter. Then it's asking you want me to estimate where that point is because it's trying to estimate the pixels. Hit enter again. And my vertex is at 4.13, 279.25. Got it? It's right here. Your x value is 4.13 and your y value is 279.25. Now, which one's the height? The y value, okay? So your y value, maximum height of 279.25 feet at, now your time is your x-axis, which is 4.13 seconds. Now, we're not done. So we're not done. Because it wants to know when the... Done. Now, I want to find out when it hits the ground. So that x-axis is where it hits the ground. We're going to have to find, by the way, what's that called when it hits the ground, that point where it hits the ground? Not minimum. It's when the y equals 0, so it's one of our zeros of the solution. So it's a 0. So I'm going to go back to calculate and pick up the 0. Hit enter, and we're going to have to do left bound, right bound again. Okay, go back to your second trace. This time I want the 0 for the equation, one of the zeros. Because that's when your y value is 0, that gives you the x-intercept. That's what, in our x, is the ground. Okay? So we hit enter. We're going to have to do that left bound, right bound thing to the x-axis. Okay? So I'm going to hit enter. And then I'm going to be to the right of that. Just make sure you're way down below somewhere. Hit enter. And then hit enter again. And your y value should be 0. If your y value is not 0 or 0.9999999 or something like that, then you did something wrong. Okay, let's do it again. Second trace. I want my 0. Hit enter. Now, my cursor here is at 8.4 and negative 14. I'm going to bring my cursor back up to a positive y value. So I'm going to hit my left, get my cursor back up to a positive y. So I'm going to hit enter. Then I'm going to get my cursor back to a negative y. Okay, negative 46. And I'm going to hit enter again, and then enter for a third time. You should get a y value for 0. A 0 for y value. Or 0.999 times 10 to the negative. What'd you get for your y value? Yeah, make sure your y is positive for your left bound. Okay, make sure your y is positive for your left bound. What's your number right now for your y? Okay, hit enter. Okay, now use your right arrow key until your y is negative. Okay, what number you got? Okay, hit enter. And then hit enter again. Okay, good. Okay, so when does it hit the ground? When does it hit the ground? 8.3 seconds. Okay? It's